central angles. First, we need to know what a central angle is. A central angle is any angle whose vertex is in the center of the circle. The vertex is that corner, okay? Any angle whose vertex is at the center is called a central angle, okay? We need to know the difference between, the reason why I'm explaining that is because tomorrow we're going to talk about inscribed angles. Inscribed angle, you don't need to write this down, you'll write it down tomorrow, but an inscribed angle is an angle inside of a circle where its vertex is on the circle. So it would go from here like this. So you need to know the difference between a central angle and an inscribed angle. Central angle is at the center. Now, what's important to know about a central angle is this. The measure of the central angle is equivalent to the measure of the arc that it creates. The measure of the arc is the piece of the circle that was created by that angle. So this angle here is equal to the measure of that arc. The measure of the arc is also a degree measure. Okay, it's strange and hard to conceptualize, but it is. So if this angle is 60 degrees, the measure of that arc is 60 degrees. Okay? If the central angle is equal to the arc. Okay? And it works the other way around too. The measure of the arc is equal to the measure of the angle. Sometimes they give you the arc, and then you have to know that the angle is equal to that also. And so, first thing they do if they tell you that the measure of arc APB is 60, follow that. APB. So that angle is 60, that means that arc is also 60 degrees. Okay? Now, special names for arcs: minor arc, major arc, and semicircle. Semicircle is half a circle, it's 180 degrees. Okay, that angle is a straight line, right? So the semicircle is here. Now, we were talking about naming arcs. When you name an arc, when we name an angle, we always use 3 letters. The vertex is in the middle when we name an angle. When we name an arc, you need to use 3 letters if there's any points between the first and the last, between the beginning and the end. You need to name one of those points in the middle. Not every point in the middle, just one of them. When you're naming an arc, it's like a road map. It's telling you which direction to go. Okay? So when we're looking at a minor arc is less than 180 degrees. So if this angle is less than 180, then this is a minor arc. A major arc is greater than 180 degrees. So the major arc is from A all the way around to B. But if I just said AB, it would go from here to here. Okay? The letters are your road map. And so this says ACB. So you start at A. We wouldn't go down to the right to C because then we'd have to come back to B. Okay? So you go A, then to C, and you end at B. That is the major arc. Okay? Because it's bigger. The angle that it creates is this angle here, and that's bigger than 180 degrees. So that's why it's considered a major arc. All right? And like we said, a semicircle is exactly 180 degrees. Any questions about that? So when you name an arc, you just need to name where it starts, where it ends, and if there's any points in between, one of those points in between. Okay? Let's look at this and check to make sure we understand what we were talking about. Okay? So here we have a figure, and they give us this information. And they want us to find the measure of these arcs. Okay? They want us to find the measure of these arcs and angles. So for number 1, they want us to find the measure of angle EHG. And so first, we need to go find that angle. So EHG, here's that angle. Well, we need to know what that angle is. Well, this angle is 60. Together, they form what? 180. So if this is 60, what's this? 120. Okay. So you're going to be looking at, when you're solving these problems, you're going to be looking at, first thing you want to do any 2 things make a straight line. Okay, that's going to fill in any missing values that make 180 degrees. Okay, because a lot of times it's definitely going to be more than just a couple lines in these circles. Okay, Then the next thing you want to look for is, are there any vertical angles? Remember, vertical angles are congruent. Okay, so some of the problems on your homework, they'll have some vertical angles. They're two angles formed by the same diameters that are crossing. Okay, so those are equivalent. So you need to remember that. Pull that back from chapter 1 in geometry. All right, so let's get back to this. Number 2, the measure of angle EHF. So EHF, that is what? 180. Very good. Makes a straight line. Number 3, the measure of arc, EG. Now, yes, because it's equal to its central angle. So that's also 120 degrees. And then the measure of arc, EFG. So EFG. So that's from E to F is 180, and then to G is another 60, so that's 240. Okay. Any questions? Okay, let's look at this problem. So find the measure of each arc of circle R. Okay, they name a circle by its center point. Okay, circle R. So for the first one, we have to find the measure of arc MN. That's 80. Good, because it's equal to its central angle. Okay. MPN. So let me use a different color. So MP to N. All the way around is what? 360, right? So it's 360 minus 80. 280. Okay? And then PMN. PMN. What's that? 180, because that's a straight line. Okay. Any questions? Okay, so you need to copy this down. These are our first 2 theorems that are deal with chords. Okay, so the first theorem says that if 2 chords are congruent, then their arcs are also congruent. Okay, this is a logical theorem. Okay, so we're looking at the measurements of the chords. If the measurements of the chords are the same, how long that chord is determines the length of that arc. Correct? So if I have two chords in the same circle and they're the same distance, their arcs are going to measure the same. If one chord's longer than the other, then their arcs are going to be different measurements. But if they're exactly the same, then their arcs will be the same. Okay? So you can, if they show you that two chords are congruent, then their arcs are also congruent, and vice versa. If they show you that their arcs are congruent, that means those chords are also congruent. Okay? Second chord theorem. If a diameter or a radius, because if it's a diameter, it's also the same segment as the radius. If it's perpendicular to a chord, then it bisects the chord. So if that segment is perpendicular, then you can assume it is a perpendicular bisector. Okay? So when you see that little perpendicular sign, you can automatically assume that these two are the same. Okay? And vice versa. If they tell you that these two segments are equal, that means this forms a 90-degree angle. Okay? Any questions? Now, when you start to see 90-degree angle symbols, that should let a signal in your brain know that you might be using Pythagorean theorem at some point to find missing side lengths. Okay? If there's a 90-degree angle, that means it can form a right triangle. For example, if I drew the radius from here to here and I knew the distance of that radius, then this is a little right triangle. I can find either one of these sides as long as I have the other one. Okay? So, in these problems, they might do this. And they might tell you that this is 10. And then they might tell you that this is 4. So if that's 4, you know this is 4, right? And then if this is the piece you need to find, if this is 10, I can draw another radius right there. That could be 10. And then I have 2 of the sides I need to find the third side. Right? Okay. So that could be a potential type of problem. All right? Know that when they give you a radius, I don't care where that radius is. If they tell you this is 10, that means this is 10, that's 10. I can draw a radius anywhere I want in that circle, and it's still going to be 10. Okay? Yeah. And sometimes that's what you have to do. Okay. Let's look at an example. Yes, it is. It is exactly the same. It's the exact same as the first theorem. Okay? What do we know? If the chords are congruent, what else is congruent? Their arcs are congruent, right? So, according to this drawing, they told us these 2 chords are congruent, which means that arc in red and arc in blue are also congruent. So, we have to find the measure of arc AD. So, we have to find this arc. So, what do we need to find first? X, and then plug it in. Okay? So, we have to set up an equation to find X. And so, we know that these 2 arcs are congruent. So, we say 2x equals x plus 40. Solve for x. So, x equals 40. Okay? They didn't ask us to find x, they asked us to find the measure of arc AD. Well, arc AD is 2x, so that's 2 times 40. So the measure of arc AD is 80 degrees. I'll tell you, for each one of the problems, when I look at a problem, I look at the drawing and I first mark everything that I know that is congruent in the drawing. I may mark more information than necessary, but when I look at the drawing, I say, okay, well, this is congruent to this because of this. And then I go and look, what do they ask me to find? Okay? So that's the first thing you should do is look at the drawing and recognize what's congruent, or what plus what is going to equal 180. What plus what is going to make a straight line? Okay? Or if you see a perpendicular symbol, if it's perpendicular to a chord, it cuts that chord in half. It's a perpendicular bisector. All right? Okay. Chord theorem number 3. Remember, the first theorem were if 2 chords are congruent, then their arcs are congruent. Okay. Well, this is another theorem involving 2 chords. This says 2 chords are congruent. Anybody know what IFF means? And it doesn't mean if. No one knows? No. It means if and only if. IFF means if and only if. It's shorthand for writing if and only if. So this says 2 chords are congruent if and only if their perpendicular distances to the center are also congruent. And I'm going to let you get that written down, and then I'm going to explain what that means. Okay, so let's look at what this means. Okay, so if two chords are congruent if and only if their perpendicular distances to the center are also congruent. Now, first thing you need to understand is why are they saying perpendicular distance? Now, if I wanted to measure the distance from me to this wall, okay? If I asked all of you, if you had to measure the distance from me to this wall right here, the whole wall on the side, if I didn't specify how I wanted you to measure, you could all get different answers, because you could measure the distance from me to that window. You could measure the distance from me to the second window. That would be different, right? Or me to this back corner, right? Everybody would get different measurements. So when we measure distance, dealing with geometry, we're talking about the perpendicular distance, because that specifies how you have to measure it, okay? So that it's a uniform measurement. You know, you heard saying the shortest distance between 2 points is a straight line, right?
No.
The shortest distance between 2 points is a straight line. Okay? So it kind of goes along with that concept. So if I measure the perpendicular distance from me to that wall, if I told everyone to do that, everyone would get the same measurement. Okay? Same thing if I had to measure the distance from me to that back wall. I could do over here or to the right. Those would be different measurements. But if I go straight at a 90-degree angle to what I'm measuring it to, if I told you that, everyone would get the same answer. Okay? So when we measure distance, dealing with geometric figures, you want it perpendicular to the figure that you're measuring it to. So that's why they say two chords are congruent if and only if their perpendicular distances are congruent. So from the center to this chord, if you drop down perpendicular, if these two chords are the same, then these distances will also be the same. The distance from the center to that chord at a 90-degree angle. Okay? And that works the other way, right? If the distances are the same, then the chords are also congruent. Okay? So that means this chord will be congruent to that chord if these distances are the same. All right? Now, looking at this figure, looking at just this figure, if I told you that this chord was congruent to that chord, what else do we know is congruent? Their arcs. Their arcs are congruent. What does this perpendicular section from the center, what does it do to that chord? It bisects it. Very good. So that's congruent to that, and that's congruent to that. Okay? So this one figure kind of pulls in all three of those feelings. Okay? So if they tell you the chords are equal, if they tell you that the distances of the chords are, if the chords are congruent, you know the arcs are congruent, and you know the distance from that chord to the center, those are also congruent. Everybody understand? Okay. See, if and only if. Let's see right, I, F. Okay. So let's look at an example now. First thing I'm going to do is I'm going to write in the information that they give me. So they tell me that AB is equal to 8. So that means from here all the way to here is 8. DE is equal to 8. So here to here is 8. Now I see that those are perpendicular to the center. So what does it do to those chords? It bisects it, right? So that means this piece is 4, this piece is 4, this piece is 4, and that piece is 4, right? It bisects it. All right. Now, it says that CD is 5. What is CD? It's the what? Radius. So CD is 5. They give us that. So this is 5. Okay? Now, we have to find CF. CF is this little perpendicular distance from here to here. This is what we're trying to find. We know that since those two chords are congruent, CF is congruent to what? CG. This is congruent to this. Pythagorean theorem. So we have to find CG, and if we know that, then we'll know what CF is. Okay? We have a little right triangle drawn right there. And so here's our right triangle. So this is 4. We don't know what this is, and that's 5. So we use Pythagorean theorem. I'll call that x. So x squared plus 4 squared equals 5 squared. So x squared plus 16 equals 25. X squared equals what? So x equals 3. Take the square root of 5. So x equals 3. So if this is 3, then that also has to be 3. So CF equals 3. Yes.
Isn't there a word for it, like how it's 3 squared plus 1 squared equals 5 squared? Isn't there a word for that?
That's a 3, 4, 5 triangle.
That's what there's a word for it. Yeah,
There might be. Okay. So there was a lot of using these theorems in place for you to be able to realize that CG is the same distance as CF. Okay? Any questions? All right, we have 2 more example problems like the ones on the worksheet. Okay? So I'm going to put those up. I want you to try and work them. And then I'll give you your worksheet. Hang on. I'm going to make that figure on the right bigger. There are 2 different problems. If this is 15.2, that's your radius, right? What's this? The whole thing.
Radius 2.
That's the radius also, so that's also 15.2. So if you figure out this, you could subtract it from 15.2 to get that. Okay, so we use this little right triangle. So I'll call this y, just because there's already an x there. Okay? So I have to say y squared plus 15.2 squared equals 13 point. No, that's not right. This is my hypotenuse. Y squared plus 13.5 squared equals 15.2 squared. 12.3 is this.
Oh, okay.
Okay? So we have y squared plus 182.25 equals 231.04. Subtract that from both sides, so y squared equals 6.98. And so that's approximately, wait, y squared equals 48, thank you, 0.79. So we take square root of both sides, so y is approximately 7. So we subtract 15.2 minus 7, and you get x equals 8.2.
Like, what's the fact? What's the subtract?
15.2, because this whole thing is 15.2, because that's the radius. So 15.2 minus 7 is 8.2. Number 2. Yes. So if this is 31.2, then this is 15.6. So again, I'll call that side y. So we have y squared plus 12.3 squared equals 15.6 squared. And you end up getting y is approximately equal to 9.6. And then again, 15.6 minus 9.6, x is 6.